Hello everyone. Today I am going to discuss how to calculate covariance matrix given some data points. Okay, so this problem is related to PCA. Okay, so here how to proceed. So to calculate the covariance matrix, we have this particular formula. Okay, which is 1 by n. This n is the total number of data samples. Total number of data samples that is given. So for in our problem, it is x1, x2, and x3. Three data samples are given. Then I will be taking summation of two matrices. The first matrix is the data point which is given and the mean of the available data point. That means I will be calculating mean of x1, x2, and x3. This matrix I will multiply with its nothing but the transpose matrix. Okay, and that final matrix will be our covariance matrix. When I will be doing the summation for all the respective available data samples and take average value, that final matrix will be my covariance matrix. Okay, so let us proceed how to solve this problem. So what is given for us? The x1 sample, x2 sample, and x3. And if I see the formula of covariance matrix, I have to first find out the x bar. So x bar is nothing but the mean of this x1, x2, and x3. And in a previous video I already have discussed that. Let me just in brief show that what I am doing here. I am taking average. There are three data samples, so 1 by 3 average of the first data sample given in a vector form, second data sample, and the third data sample. So all these so first data sample 2 2 okay, so class 1 2, not this one, class 2 1. Okay, I will be taking average of all this, and this value is nothing but 1.67, which is again a vector of two dimension of two features. Okay, so now what I have to do, I have to, for I equal to 1, the sample number 1, because I will do summation from I equal to 1 to n, right? Total 3, n is equal to 3 number of samples are there. For I equal to 1, first I will be calculating what? The first sample subtracted by the mean of all the samples. So this is what this will be. First sample is 2 2 vector of 2 2 minus what was the mean value just now we have calculated, right? That is 1.67, 1.67. Okay, so this is nothing but the final value will be 0.33, 0.33. Okay, then what I will be calculating now? I will be calculating x minus x bar, this matrix multiplied by its transpose, right? x1 minus x bar transpose. Why I am calculating? Because you see this formula, right? I have to calculate this matrix multiplied by its transpose only, right? So what will be this value? Let us proceed here. So x1 minus x bar, that is just now I have calculated 0.33, 0.33, and what will be the transpose matrix? That is nothing but 0.33 and 0.33. So here you see the size of these matrices or vectors. Okay, here the size is 2 by 1, 2 number of rows, 1 number of column is there, and the transpose matrix, what is the size? 1 by 2. So it is compatible for matrix multiplication, right? So what will be the final size of the matrix? The final size of the matrix will be 2 by 2. Yes, 2 by 2, because here 2 by 1 multiplied by 1 by 2. So final size will be 2 by 2. So let us now calculate how I will be proceeding for this. This particular first row and the whatever the only column that is available, then first the only row that is available and the first column, right? First I will be multiplying this to 0.33, multiplied by 0.33. Okay, then I'll proceed for the second first row but the second column. Okay, so that is again 0.33 multiplied by 0.33. Similarly, now I will be proceeding for the second row. Okay, second row first column. So here it will be the only row that is available and the first column. Again that these values are same only, 0.33, 0.33. Then the second row and this second column. Okay, so it will be 0.33 multiplied by 0.33. So this final value after calculation, that is nothing but 0.1089 0.1089, all the values are same, right? 0.1089 0.1089. Okay, so this is my the first for I equal to, for the first sample I have calculated just now. Similarly, I will be calculating it for the second sample as well. So for the second sample, x2 minus x bar, what will be these values? The x2 value, that is 1 2. Okay, minus what was the mean? 1.67 1.67. Okay, so final value is minus 0.67 and 0.33. Okay, these are the two values. So now I will be having transpose for it and multiplying, doing the matrix multiplication, x2 minus x bar transpose. So it will be minus 0.67 0.33 multiplied by transpose minus 0.67 and 0.33. Again, as I told, this is 2 by 1 matrix and this is 1 by 2 matrix. So it is compatible for matrix multiplication. So final value, the final matrix will be of size 2 by 2. So how to do individual multiplication, that I have shown for the previous step only. So I will here directly put the final values, 0.4489 minus 0.2211, then minus 0.2211 and 0.1089. Okay. So similarly, I will also calculate for what? For the third sample. For the third sample, let me put the final value directly here, because the steps are very easy and we already have seen all. So the final value is 0.33, then minus 0.67. Okay, and the transpose multiplication with the transpose will be this x3 minus x bar transpose. The final value here, again it will be a 2 by 2 matrix. The final value here will be 0.1089, then minus 0.2211, then minus 0.2211 and 0.4489. Okay, so these are the three matrix multiplications that we have seen. Now what I have to do finally, will again revisit the formula here. Once we calculate for all the data points this matrix multiplication, I have to add all those particular matrices and also then take the average, right? So we will do that only. So here let me take another new blank place here, blank page. So final, the covariance matrix, which is denoted by C, suppose. So it will be what? 1 by n equal to 3 here. So this is 3, and all the matrices that I have that I have calculated in the first attempt. For the first sample it was 0.1089, then 0.1089, 0.1089, 0.1089. This is the first matrix, and I will be taking average of all this, plus for the second data sample, what was the 2 by 2 matrix that I have got? It is 0.4489, then minus 0.2211, then minus 0.2211, then 0.1089. This was the second matrix. And what was the third 2 by 2 matrix that I have calculated? 2 by 2 matrix, it is 0.1089, then minus 0.2211, then minus 0.2211, then 0.4489. okay, so the final values here, it will be equal to 1 by 3 summation of all this value plus this value plus this value, right? This sum is 0.6667 minus 0.3333 minus 0.3333 and 0.6667. okay, after the division by 3, the final matrix, which is my covariance matrix, that is nothing but 0.22 minus 0.11, then minus 0.11, then 0.22. okay, this is the final covariance matrix for the given data point x1, x2 and x3. okay, so the answer, if we go back to the available options, so here you can see that option A, 0.22 minus 0.11 minus 0.11 0.22, this is the correct answer for this particular problem, that is covariance matrix calculation. okay, thank you.